Let us now study about oscillations in LC circuits. Okay, so we learned about LCR circuits now. Okay, series LCR circuit we learned, that is an inductor, capacitor and a resistor in series we learned. Okay, now we're going to study about the energy conversion during LC oscillations. That means, okay, see, it's a scientists have found that there's a special kind of circuit is there which produce a wave there. Okay, see, that forms the basis of all the radio communication. Okay, see, we have a mic, we speak in a mic. Okay, FM mic is there. Okay, so what happens is that FM mic will change the wave, okay, or the sound signal into electrical signal, and that signal is changed into FM wave. Okay, that wave will go from one place to another place. Okay, next one, we also see we have another remote here. I'll show it to you. One minute, taking it out. Okay, now I have a small remote here. This is a Bluetooth remote. Okay, when you switch it on, okay, you can see it's searching for the device here. Okay, and when you press this button, it will take a photo. Okay, that's why it is there. We can also use for car remote and keys are there. So inside this circuit, inside this remote, what happens? There is an LC circuit there. Okay, so let's see how the circuit is. Okay, let me switch it off. Put it down. So let us see this part here. So just like the series LCR circuit only now, okay, it's like this way. Okay, there's a coil here, L. This coil is called as a inductor coil here, that is L, and we have a capacitor here. Okay, it's like the series LCR circuit only. Okay, in series LCR circuit, what happened was we had this thing now. Okay, L, then we had the C, that's capacitor, then we had the resistor. Okay, so now you see that resistor is very less. Okay, so we only have a inductor and capacitor. We bend the circuit. Okay, so this is the inductor and this is the capacitor. Okay, the resistance is very low here. Okay, this need not be drawn. Okay, it actually have some little bit of resistance. Okay, but now you see, when you give an energy to it, okay, the energy will be stored in the inductor, that is in the form of magnetic fields. Okay, and the capacitor is stored in the form of electrostatic fields. Okay, so how is the energy stored here? The energy is stored in the form of magnetic fields here. Okay, so in the inductor, energy is stored in magnetic fields. Okay, we remember inductor will produce a magnetic field when current flows through it. Okay. Okay. In the inductor, inductor part, in the capacitor part, what happens? Energy is stored in the form of electrostatic field. Okay, so energy, that will say now how it is. Energy is stored in electrostatic field. That is magnetic field and this is electrostatic field. How would the magnetic field be there? When current passes through the inductor, you can see there is a magnetic field producer in this coil here. Okay, so this magnetic field will store the energy. Okay, next in the capacitor, what happens now? When current passes through it, it will get charged up now. Okay, positive charge and this side negative charge. So there will be an electrostatic field here. The electrostatic field inside the capacitor will go from positive to negative in this direction here. This is the direction of the arrow marks. Okay, so capacitor will store electrostatic energy and inductor will store the magnetic energy. Okay, so this will change. The energy will be changing from one form into another form. Okay, and it will produce a wave there. Okay, so the wave produced will be like this wave. Okay, typically, okay, it will produce a wave here, and that wave will go from one place to another place. That's what you use in the radio circuits. We have the TV, cell phone waves. Okay, so all these things have the LC circuits inside it. Okay, this is very important. Even satellites we have now. We send a signal to satellite. Satellite will send the signal back to it. The satellite will contain an LC circuit inside it. Okay, so these are very important parts here. Okay, so let's now see next part, that is generation of LC oscillations in the next video.